We're standing on an academic field research site. That is the transition from research that happens, in this case, at the Donald Danforth Plant Science Center here in St. Louis, as the journey goes from a discovery to actually being in the food system and producing plants for the future. So the plants behind me represent a lot of questions on how plants interact with their environment and how can we position those plants and arm those plants to produce food better in the future as the climate gets less friendly and less predictable.
There's no more land being built. In the U.S., there's 198 million acres of row crops in agriculture, and that's not growing. And so we have to do better, grow more sustainably, and better food in the space that we have.
One way to do that is to integrate new technology into the age-old methods used in farming.
What exists today is technology, whether satellite, airplanes, and others, that actually look at your farms so they become the eyes of the plants that you grow. We use drones, so we have a very unique technology that goes inside the plants to find the outbreak of disease, pest, pressure, at the moment of outbreak, when that happens, when the growers care the most. We patented a method to actually essentially use a tether. It's essentially a selfie stick where the drone is flying above, but the cameras are off the actual drone, tethered, and that's how we lower. Instead of actually having people walking the fields, we do that with robots instead of people. Between the plant, we lower a set of cameras and we take pictures of anything like the insects. When they actually happen, they first occur underneath the leaves, and that's where they kind of like harbor. The same thing with weeds. So where do you have weed pressure that matters the most? It's actually when the weed is very, very small. So you have to know that, and that you cannot know from above because you have the canopy, the crop itself. So you have to get inside to understand what's happening underneath.
That device, developed by Aker Technology, is called TrueCause, and the information it collects allows farmers to assess their fields more accurately as well as efficiently.
I'm a farmer from Illinois. We raise corn and soybeans and wheat primarily. And we'll be looking at the fields a lot like we would be doing if we were out in them, but it's a lot faster way. There's some artificial intelligence here that can tag some of the images for us to be able to tell us exactly what to look for and focus our attention on so that we're very efficient when we're sitting in front of a computer and looking at it. And so it's going to be a lot more timely than actually going out and walking the field. You can cover a lot more acres.
The information that is collected by the sensor that falls off the drone is a sensor array, and it collects a number of agronomic things. The first, it takes pictures, and those pictures are translated using machine learning, artificial intelligence, into things that matter to the doctor or the agronomist. We also capture environmental information, temperature, humidity, CO2, O2, all kinds of things that are important to understand the variability of soil, temperature, and conditions that are important for the plant to thrive.
We're applying insecticides or fungicides or different nutrients to different areas of the field that need it versus areas that don't. And again, having it tagged spatially within that field, we can do a much more efficient job, so increasing our return on investment.
The hope is that in addition to helping individual farmers, the information gained through the use of this new technology will also give researchers the ability to design new and better crops that will help increase yield in light of changing climates throughout the world.
This research isn't impacting climate change, but it is very much impacting how plants will perform in that climate and understanding what levers we have inside plants, whether it's their architecture or their biological, physiological responses to the environment. So you get more data, which is going to let us improve crops better for their environmental performance, but also quicker.